Hi fellow mathematicians, welcome back to another video. We are not talking about quadratic functions today, but rather about linear functions, because a student of mine actually gave me a very nice exercise that combines steady motion, so constant motion in physics, and linear functions in a very nice exercise. And we are going to talk about this as a little application of linear functions. And it's a very clear exercise and I really like it, and hence I want to present it to you on this channel. So here's the scenario. We have two cars which are 100 kilometers apart from each other. And now here's the scenario. This car is moving towards this car and this car is moving towards this car. Meaning they have different velocities in our scenario and they are moving towards each other like that. And we are going to suppose that this car right here is going to move with 50 kilometers per hour and this car is moving with 30 kilometers per hour. And like mentioned before, towards each other, and the motion is constant, meaning they are going to have no acceleration. It's just a constant motion all the time of 50 and 30 kilometers per hour respectively. And what we want to find out is the time after when those cars are going to collide basically, or meet somewhere in the middle, we don't know this yet, and also what the distance was that each of those cars were traveling. And now we are going to dive right in. So for clarification purposes, I'm going to draw a distance time diagram really quick. So a graph which combines both linear functions basically of those cars moving. So we want to visualize the motion of these cars. So that's the distance, and this right here is just the time axis. And now we are going to start off with this car. And for simplification purposes, we are going to assume that this car is going to start off at 0 kilometers, basically at a starting line. Meaning, overall, since this is a constant motion, no acceleration, we are going to have a linear function overall being the graph of this function describing the motion of both of these cars. And this linear function describing the motion of this car is especially a proportional function because it's starting at 0 kilometers, and kilometers is the unit of our s-axis basically. Meaning it's going to start at the origin in some way. Now, we are basically going to find out with which rate this car is moving over time. And that's actually really easy to find out because since it's a constant motion, we know that it's moving 30 kilometers for every unit of hour. Meaning, after 1 hour, it's going to move exactly 30 kilometers. And now we can put our point here, and we know that if we have 2 points, we can connect them uniquely to a linear function. And this right here is a linear function describing the motion for our first car. Now what about the second car? It's a tiny bit more complicated, but we are going to take as a reference frame this car to describe the motion of this one. So if we sit in this car basically, and it's not moving, let's just suppose that. This car starts moving towards us, meaning at the moment if this car starts at 0, this car starts at 100 kilometers away from us, meaning it has a certain y-intercept, which is at 100 exactly. So looking out of the window from this car, we can notice that this car is 100 kilometers away from us when we start at 0 kilometers. And that's an important fact because we now have a y-intercept, and this is going to be put into our equation later. Now, what about the motion of this car? I mean, obviously it moves with 50 kilometers for each and every unit of hour, okay? Per hour it moves 50 kilometers. But the thing here is, if we look out of the window of this car is moving towards us. Meaning, if it starts at 100 kilometers at first, after 1 hour it's going to be at 50 kilometers. And then after 2 hours it's at 0 kilometers. Meaning actually it's moving towards us and it's basically performing a negative distance over time towards us. Meaning from 100 kilometers after 1 hour we are going to only be at 50 kilometers over time. Meaning this right here is going to be another point in our coordinate system, and now we can connect points. Which does make sense if you think about it. I mean, they have to meet somewhere at some point, meaning this car is going to move towards this car with a negative velocity, you could say, but just in the reference frame of this car. You can go through the same process with the reference frames changed, okay, then basically this right here, this car is going to have a y-intercept of 100 and this car is going to have a y-intercept of 0. Now, here is the most important thing in our visualization, namely we're going to have this being the intersection point, meaning this intersection point is going to give us the time it takes for the two objects to collide, so for the two cars or to meet into the middle. And also, after we found out the time, we can just use simple cross multiplication to find out when or after which distance those two cars basically meet in the middle. Now at first we're going to get ourselves a function for the first vehicle, meaning we are going to find out which number of kilometers it does take away over time. So function with respect to time, hence the diagram right here. So like mentioned before, it has a y-intercept of 0, meaning it's just of the form slope times the time unit. In normal case we had an x unknown right here all the time, but this time we are dealing with a time-dependent function. So instead of x there's a t here, but don't be confused about that. Now, what is the slope exactly? I mean, we can use simple slope triangles or cross multiplication in general. Let us go with the slope triangle version, meaning we're going to look for a delta y and a delta t, and then we are going to divide both by each other. Meaning our delta y from 0 to 30 is going to give us 30. Our delta t from 0 to 1 is going to give us 1. Delta y over delta t is 30 over 1 is nothing but 30. Which does make sense unit-wise too, because 30 is exactly our 30 kilometers per hour. And that's a nice hint here to find out the slope. Namely, unit-wise, this is going to give us kilometers per hour multiplied by a time unit, which is hour. Cancelling that out gives us kilometers, which is exactly a distance, which we want to find out. Now, what about the second function, s2, with respect to t? Now, the second function is going to be of the same form, basically, just with a different y-intercept. So the y-intercept we know is nothing but 100. So we need to add 100 kilometers to it, basically. And now, once again, we are going to have some slope times the time unit t. Now here's a bit of the part where you need to pay attention to. Namely, we are having a decreasing function. This car is moving towards this car and performing a negative distance over time. Meaning we are going to have a negative slope overall. You're going to find this out by putting the slope triangles in here yet again, but you don't even need to do this because we know that we have a constant slope all the time, namely 50 kilometers per hour. It's just like here we had 30 kilometers per hour being the velocity that our car had. And now the velocity is 50 kilometers per hour. And hence we are done. This right here is the second function. And now we can start equating both equations. So S1 being equal to S2, giving us in the process our intersection, basically, our time it takes for the two objects to meet in the middle somewhere. Now if we were to equate both, then we're going to get that 30t, so just plugging those equations into here respectively, hence nothing but negative 50t plus 100. And now we can just start solving for t, namely we can add 50 on both sides, 50t, leaving us with 80t being equal to 100. And now since 80 is not equal to 0, we can divide both sides by 80. Leaving us overall with t, so the time it takes for the two cars to meet in the middle, hence nothing but 100 divided by 80. And well, we can cancel out the zeros here, so the 10th place, then we have 10 over 8, which is nothing but 5 over 4. And this right here is the time, meaning this is 5 over 4 hours is the time it takes for the two cars to meet somewhere. So 5 over 4 is nothing but 1 whole hour, definitely, so 1 hour, and 1/4 of an hour. 1/4 of an hour is 15 minutes. So we also got 15 minutes here. And now we just need to find out what the distance, for example, is that our first car actually took over a certain amount of time. I mean, it's rather easy actually, so the distance for the second car. For this time unit, I mean, you can just plug it into here and see what you're going to get. Or you can think about it for a second, namely 1 hour gives us 50 kilometers already, because 50 kilometers per hour. So we definitely have 50 kilometers going. And now we will need to find out how many kilometers our car actually takes in 15 minutes. I mean, this is just 1/4 of 50 kilometers, meaning what is 1/4 times 50 kilometers? What times 4 gives you 50? I mean, this is 12.5, meaning this right here is 12.5 kilometers. And 50 plus 12.5 is going to give you 62.5 kilometers. And this is the distance that our first car takes to meet with the other car. Now what about this car? What's the distance that it takes in the same time? I mean, it's fairly easy to find out because we just need to find out what's the difference between 100 and 62.5. This is going to give us 37.5. And hence we are done. Oh yeah, this was the question. I hope you did enjoy it. If you did, please like, subscribe, and comment channel if you like. If you want to see more applications, then please let me know. Just want to put this here on the channel because I thought it's a very nice exercise. Thank you guys for watching. Don't forget to check out the main channel too and the merchandise. And up until the next video, I wish you guys a flammable day. Ciao!